Good morning, students. Today we are going to discuss some important topic related with the chapter 10. And the chapter 10 is your mechanical properties of fluids. Now the first topic which we are going to discuss is your terminal velocity. Now what is terminal velocity? Let me try to define. When a body is dropped in a viscous fluid, it is first accelerated and then its acceleration becomes zero and it attains a constant velocity called terminal velocity. So you can say the terminal velocity is your constant velocity. Here in the figure we have trying to explain when you drop an object in the fluid, what will happen? Some forces acts on the object. One is your viscous force, which is against the direction of motion, and as the object is getting down, so capital F, that is your viscous force, is acting upward. Similarly, it has upthrust, and that upthrust acting in upward direction, and only the force which acts downward direction is nothing but the weight of the object. Now as per the definition, if you drop an object in the fluid, first of all it accelerates, but after that or after some time it moves with a constant velocity, and that velocity is nothing but the terminal velocity. So in equilibrium you see the upward force must be equal to the downward force. So upward is your F and U. F is your viscous force and U is your upthrust. So F plus U equal to W. Now F is your 6 pi eta V, that is your Stokes law. Previous class we have defined. And U is your upthrust, and upthrust is nothing but the 4 by 3 pi r cube sigma g. Sigma is your what? Density of the liquid, and W equal to mg, 4 by 3 pi r cube rho g, and rho is the density of the object. Now upthrust is nothing but the upward force which causes by the displacement of the fluid responsible by the object. So it depends on the amount of fluid displaced by the object when you put the object inside the liquid or in fluid, and that is nothing but the volume of the liquid displaced. So that's why we have written in case of upthrust 4 by 3 pi r cube sigma. Sigma is the density of the liquid. Now if you substitute this thing in 1, you will get F equal to W minus U. So F is your 6 pi eta V, W is your 4 by 3 pi r cube rho g, and rho is the density of the object, minus 4 by 3 pi r cube sigma g. Sigma is the density of the liquid. So 4 by 3 pi r cube rho minus sigma into g. So V equal to 4 by 3 pi r cube rho minus sigma into g divided by 6 pi eta r. So if you simplify, it comes out to be your 2 by 9 eta r cube rho minus sigma g. So this is the expression for the terminal velocity, and sometime in exam it is asked to find the expression for the terminal velocity. And terminal velocity is your constant velocity with which an object moves under the zero acceleration. So this is your important topic, that is your terminal velocity. Please go through and try to find out your query. Now next topic which we are going to define is your surface tension. So I think most of you observe this phenomenon, but you don't know the term. So today we are going to discuss this topic, surface tension. So tension is nothing but some kind of force, no? And here the force acts on the surface of the liquid or the surface of the fluid. So let me read out what we have written. It is a property of a liquid at rest by virtue of which the liquid surface tends to occupy a minimum surface area and behaves like a stretched membrane. Let me repeat once again. It is a property of a liquid at rest by virtue of which the liquid surface tends to occupy a minimum surface area and behaves like a stretched membrane. So it becomes more clear once we explain this theory, molecular theory of surface tension. Now you see in this figure we have taken a container, and the container contains certain amount of liquid. Now the liquid have millions of molecules. Now here we have considered few molecules A, B, C, D, E. Now if you consider a molecules at A, that molecules get pulled by all the molecules surrounding it. So the force is in all direction. So you can say the resultant force on the molecule A is 0. Similarly, for the molecules B, it experiences a force in all direction by the nearby molecules. So ultimately, the resultant force is 0. And this happens for E also. But for C and D, you see the force is in left direction, right direction, and downward direction. Left and right, these are balances each other, but the downward force can't be balanced by the upward force. So what will happen? C molecules try to getting down, and D also, molecules also try to getting down. So you can see all the molecules which is available on the level AB trying to getting down. But if you see the molecules which is in stick with the wall of the container, there are some kind of different forces are there. At the wall of the container on the level AB, there is an adhesive force. Adhesive force in the sense force between liquid molecule as well as the molecules of the wall of the container. So you see at the corner, the molecular force is not identical compared to the molecular force which we are considering in C and D. So there is an imbalance of forces at the wall of the container and the molecule which is available in between wall. So due to imbalance of the force, if the corner molecular force is high and CD molecular force will be low, then what will happen? It becomes a convex. Okay, if the molecular force on C and D is high compared to the molecular force between A and B at the wall, then it is your concave. So based on the magnitude of the forces at the corner as well as at the middle, the nature of the surface becomes one time concave or another time convex. Okay, so ultimately you can say there is always a downward force X on the molecules which we have considered C and D, and this makes the surface sometime curve, one time concave, one time convex. So it means curved surface means minimum surface area. How can we measure the surface area? In this topic or in physics basically we'll measure the surface area with the respect of the contact. Now if you consider a spherical surface, the contact is less, so we consider this one as a minimum surface area. If the contact is more, then it is maximum surface area. So you see surface tension try to maintain a minimum surface area, making the flat surface curve. So here what we have written, the molecules A, B and E are pulled in all direction with equal amount of force, and hence the resultant force is 0. The molecules C and D have resultant force in downward direction because left and right get cancelled out, but there is no cancellation for downward, so that's why it gets pulled downward. Now you see as the molecules A and B or E get pulled in all direction by the molecules available surrounding it. So if you have to take the molecules from interior of the liquid to the surface, you have to do work against this force, and this work gets stored on the molecule as is potential energy once you take the molecule from interior of the liquid to the free surface. So this part we have written, some work has to be done to move a molecule from the interior of the liquid to the free surface. This work gets stored on the molecule as is potential energy. The potential energy of surface molecules per unit area of the surface is called surface energy. So this is one more topic, surface energy, and surface energy is nothing but the potential energy by area. This topic we are going to use later on. Now next let me come back to the surface tension again. How can we measure the surface tension numerically? So what you have to do, you have to consider an imaginary line on the free surface of the liquid. Here we have considered the imaginary line is your AB of length L. So the molecules available on the line AB gets pulled in both direction, left as well as on the right. So you have to find out the resultant force on either direction. So if F is the resultant force on either direction, then surface tension is nothing but T equal to F by L. F is the resultant force on either side of the imaginary line, and on the imaginary line the molecules are there, so it gets pulled by the nearby molecules. So T equal to F by L, this formula we are going to use it in numerical, and the unit is your Newton per meter, and dimension also T. This T does not get confused with the time. For dimension there is that T is time and this T is your surface tension. So T equal to m1 L1 T minus 2 and L1. So L1 L1 goes off m1 T minus 2. So this is all about. Please go through and try to study, because in physics you must have to study. You are not supposed to go through in just on the top of the topic. You have to go inside the topic. So please try to find out your doubts and make the things clear. Make your habit to study. Okay. So this is all about. Thank you.